Welcome to a co-engineering YouTube channel. Today we discuss about Gauss law. Here in Gauss law there are three statements there. Now we discuss the first statement. The statement 1. It states that total displacement or electric flux through any closed surface surrounding the charge is equal to the amount of charge enclosed. Whenever the charge is equal to the amount of charges enclosed, which means it state that total displacement or electric flux through any closed surface surrounding the charge is equal to the amount of charges enclosed. Whenever it means the total whenever what is the input charge is equal to the output charge. This is called stated statement 1. Gauss law statement 1. Gauss law statement 1 is stated. It stated total displacement or electric flux through any closed surface or surrounding the charge is equal to the amount of charges enclosed. The explanation of the statement on or proof. Let positive charge let positive point charge q be placed at the center of imaginary sphere of radius r. In finitely amount of electric field d psi through the surface element ds is rho d psi is equal to d dot ds, capital D dot ds, electric flux density. If this integrated over the surface of radius r, total electric flux psi through the sphere is obtained. Integral of d psi is equal to double integral of d dot ds. Here d psi is equal to double integral of d dot ds. We know that d is equal to epsilon e. Here d is equal to q by 4 pi r square, and ds is nothing but r d theta r sin theta d theta. Here ds is equal to r square sin theta d pi. R ds is equal to r d theta r sin theta d pi. How to write these values means because of in this vector formation there are three formational coordinates are there are three coordinates. One is Cartesian coordinate and cylindrical coordinates. One is Cartesian coordinates and cylindrical coordinates, and also spherical coordinates. Here Cartesian coordinates are nothing but Cartesian coordinates and spherical coordinates. The first coordinate is Cartesian coordinate or rectangular coordinate. The second coordinate is spherical coordinate, and third coordinate is circular and cylindrical coordinates. In we have to find out r theta pi. This is spherical coordinates. Here r d theta r sin theta d pi means r square sin theta d pi is spherical coordinate. This is called as spherical coordinates. Ds is equal to r square sin square d theta d pi. Now, this is a structure of construction of the circle where uniformly distributed over the sphere. This is a sphere. This is the radius small r. This is a field r. This is normal. This is a tangent. The point charge q. This is the direction how the electric field is produced along the sphere. And this is a point charge q placed at the sphere of coordinates. This is coordinates. This is an x coordinate and y coordinate and z coordinate. In this coordinate, this is in a space of arcs like this, which makes the angle phi. This is positive charge q, and this r dt r d pi r d pi sin theta dt d theta and r d theta. This is the value d r sin theta. This is the mixed angle of r theta. This is a mix of angle r d by d theta. This is a mix of angle d theta. This is a mix of angle r d theta. This is the point charge of place at the spherical coordinates. This makes angle phi. This makes angle d phi. This makes an angle. This the distance is r. Now psi is equal to double integral of q by 4 pi r square sin theta d pi. Here psi is equal to integral theta means theta pi theta to 0 to pi and pi to here 0 to pi and 0 to 2 pi. Here for q by 4 pi r square sin theta d pi. Psi is equal to q by 4 pi into 0 to 2 pi sin theta d theta 0 to 2 pi d pi. Here psi is equal to q by 4 pi. Here integral of sin theta is equal to minus cos theta integral 0 to integral from 0 to pi. Here integral of d pi is equal to pi 0 to 2 pi. Here cos pi value is minus 1, sin cos 0 is 1. Here q by 4 pi, cos pi value is minus 1, cos 0 value is 1. Here 2 pi value is 2 pi, here 2 pi minus 0, 2 pi, here 2 pi value psi is equal to q by 4 pi, q by 4 pi 2 into here this minus 2 into minus plus 2 into 2 pi psi is equal to q by 4 pi into 4 pi, 4 pi cancel q, psi is equal to q and close. Hence the displacement or total electric flux over the surface or the surface the sphere is equal to the charge enclosed by the sphere. This is how to, this is why the statement want to be proved. Psi is equal to q and close. Hence the displacement of total electric flux over the sphere is equal to the charge enclosed by the sphere. Now the statement 2, Gauss statement 2, the surface integral or of the normal component of the electric flux density d or any closed surface is equal to the charge enclosed, or symbolically surface integral double integral of s d and ds is equal to double integral of s d cos d theta ds is equal to nq enclosed. Here surface charge integral of the normal component of the electric flux, normal component of the electric flux density d or any closed surface equal, any closed surface equal to the charge enclosed, or symbolically surface integral is equal to double integral of s double integral of s dn ds is equal to double integral of s d cos theta ds q enclosed. If the charge is continuously distributed throughout the volume with charge density rho v, then the total displacement through the surface is psi is equal to triple integral of v rho v dv is equal to q enclosed. Here q is equal to triple integral of v rho v dv is equation 3. This is equation 1, this is equation 2, this is equation 3. Combining equation 1 and 2, 1 and 3, then we get here double integral of s dn ds is equal to triple integral of v rho v dv is equal to q enclosed. When the charge is enclosed, hence total electric flux over the sphere is obtained by integrating the normal component of electric flux density d over the sphere is equal to the charge enclosed by the sphere. Total outward displacement through a closed surface is equal to the charge contained in the volume enclosed by the surface. This is a vector statement of Gauss law. The total outward displacement through enclosed surface is equal to the charge contained in the volume enclosed by the surface. This is vector statement of Gauss law. Now we discuss the statement 3. Gauss law states that at every point in a medium, divergence of electric flux density d is equal to the charge density rho. Symbolically, divergence dot d is equal to del dot d is equal to rho v. Here, Gauss law states that at every point in a medium, the divergence of electric flux density d is equal to the charge density rho. Symbolically, divergence dot d is equal to del dot d is equal to rho v. Apply divergence theorem to convert surface integral into the volume integral is double integral of s dn ds is equal to triple integral of v rho v dv, or triple integral of v del dot d dv is equal to triple integral of v rho v dv is equal to q enclosed. Here del dot d is equal to rho v is an important relation and is one of the Maxwell's equation. Del dot d is equal to rho v is important relation and is one of the Maxwell's equations. How to discuss Gauss law applications, Gauss law, statement 1, statement 2, statement 3. Here this is one of the important relation, that is Maxwell's equation del dot d is equal to rho v. Thank you friends, thank you very much.